All right, so once we update the health checks, it's going to redeploy, right? Okay, so um, like I said, you can look at the logs whether it is doing health inquiry or not. It is doing health inquiry, so that means it is really checking for health of this application. Let's do this thing. Let's go and make one of these container unhealthy, and OpenShift should automatically remove that container from the cluster of your application, so that there will not be any impact on the incoming traffic. Okay, so if you look at the incoming traffic here, it's still good. There are no interruptions at all. Okay, even your rolling deployments did not impact anything here. So what I'm going to do is I'm going to hit the cancer endpoint that we have here, which makes one of these containers unhealthy. Okay, so when I hit this URL, it is going to go to one of the 4 containers. So it's going to really make only one of them unhealthy. So I'm going to make this unhealthy. So I have killed HHK 4 to 7. Okay, if you look at the traffic, it's still good, right? There is no interruptions at all. So let me scroll up to see that traffic is still good. So even if we have a bad container that is running, it will be automatically taken out from the cluster, and it will be self healed. And once it is healed, it will come back again. Okay, so this will basically take care of a lot of operations aspects, so you can basically sleep peacefully, right? Yep. So I have my container 4 healthy containers back again, and still no interruption on the traffic. Okay. Uh, with that, let me also show you some of the debugging capabilities of OpenShift. What I'm going to do is I'm going to make the MySQL container unhealthy, and then show you how to debug any application that is unhealthy. Okay, because I don't have any unhealthy containers now, I'm going to make one of them unhealthy, and then show how to debug that. Okay, click on these deployments and MySQL. So if I remove this environment variable, the MySQL container is going to be unhealthy. Okay, I removed that environment variable and then saved it. You can see it is making a new deployment now. Okay, and the container is now in an unhealthy state. It shows orange in color. Okay, how do I debug this type of container? So this can be any application. It need not be just MySQL, right? It can be any application, your application which is not healthy. So how do I debug this? Click on this container, and then in the details section you have a debugging terminal. So if I go here, basically it will open a debug console for me, so you can go investigate what is wrong with that container. Okay, that's it. It's super easy, very convenient to address. And one other important feature I want to show is how OpenShift behaves when your newer deployment is not correct or not deploying fine. Okay, um, what I'm going to do now is deploy a new container, a new version of this application, but purposefully I'm going to make it unhealthy, so that this application will check for the readiness probe, and that readiness probe will not be able to reach, and it will not be able to verify that readiness, and then it should not basically add it to the cluster or deploy a newer version at all. Okay, so let's go here, and then if I change this parameter to false, it's obviously going to say unhealthy, because all I'm checking is this binary this boolean, right? I click this commit, and this application is running. It did not deploy by default because I did not set up the GitHub webhook. I'm gonna start the build again. So it should deploy a newer version of the application with the changes I have made in the Git repo. Okay, and you can look at the traffic, incoming traffic, see that the newer version is not healthy, so it's not really transferring your traffic to the newer version. So you still see the v2 version, right? Or it's basically not going to the newer one, because it identifies that your newer version is unhealthy, and it's not going to do the deployment at all. Okay, let's verify, waiting few more minutes. Although it went to 3 parts, it will verify that the newer version is not healthy, and it's going to auto heal itself. Okay, so you have a bad deployment, but still you are safe. So how do I roll back from this? Just go here, OC rollout, do a help on that. So if you want to look at the history of the deployments, you just choose the history, right? So history, and then you want to look at the welcome deployment. Okay, sorry, DC deployment config, and then look at the welcome deployment. So it says it's currently at 6, but it's not able to deploy it completely. Okay, so we are going to roll back to the deployment, 5th deployment. How do I do that? Just to again rollout -h. That should show you how to undo that. So rollout undo and deployment calling welcome. So I'm just rolling back to the original version again. Okay, give it a few more minutes and it should fix it. That's all I need. So nowhere in the deployment process you have seen any interruptions in your incoming traffic. Your incoming traffic is still good. Okay, so we are doing a lot of changes on the environment, but your traffic is not affected by your deployment. So what does it mean? So you have a lot of flexibility to deploy often and also deploy faster. Even then, your system is stable enough to address all of these issues. Okay, I'm going to close these and show you some other interesting feature, traffic split feature. So this is like a partial Canary deployment. So you have 2 versions of your same app running, and what you do is basically split traffic in between both of them. Okay, so for that, let me change something on this version so that I can demo 2 versions of the same app. So I have a newer version which is Hello World v3, and I'm going to make it true again so that it is healthy, and then commit. Sorry. Okay, I'm going to deploy a newer version. So it's this Node.js app, and I'm going to call it welcome new, and it's from the same repository. So this is useful if you want to roll out your changes carefully by splitting your traffic to the newer version, very slight traffic to the newer version, and see how your changes are affecting your users. Okay, so I have a newer version of your application. If I go click on this newer version, it shows we have v3. So you have a URL which is basically exposed internally, or you can just use, which is known only for you, and you can hit this URL and see how the newer version is. Okay, if you don't want to expose this URL, you can still use it based on the service which is only internal to the Kubernetes. I'm going to scale it to 4 and make it similar, or let's make it both of them to 1. same thing. Okay, you don't need to do this, but I just want to have consistency between these two, so I'm gonna scale it like to the same amount. Once these are scaled, wait for a few seconds. So partial canary means you can basically split your traffic between two versions of your application, but you may not be able to basically out of the box choose some other parameters, like if you want to target your deployment, your newer deployment to only a specific geography, you may not be able to do those kind of customizations out of the box. Although if you have customizations built into your applications, you can do that, but out of the box it supports straight traffic split. Okay, so I have my two versions running, old version and a new version, and this is a production URL, right? So this is actually what I'm using now. So what I'm going to do is click on applications and split the traffic. Okay, so I'm taking the old URL here and click on edit and split traffic between multiple services. I want to split traffic between welcome and welcome new. And how much do I want to split? Like let's say 50-50, or you can choose 99-1. It's up to you. Once I split the traffic, these are combined together, and 50% of the traffic is going to the new older one and 50% going to the newer one. You still see that your application is not taken down, and there is a split of traffic between version 1 and version 2. Okay, super easy. And let's say you have some issue with your newer version, you can just go into routes and then take that out from the route. That's all you need. Super easy. Nothing, no tooling that you need to build around your applications. Okay, um, this helps operations a lot in saving their time and just focusing on application deployment and development. Okay, um, with that we have seen most of the operational aspects. Um, one more important feature before I jump into the other development activities. Let's say this application is currently consuming 100 MB of memory. I want to restrict this to with some limits. Okay, so go to deployments and click on set resource limits. I can specify how much this CPU can consume, how much this application can consume with respect to CPU and memory. CPU you can mention in millicores and cores. Let's say this needs some 50 cores minimum and 60 maximum. So what does it mean? 50 is what guaranteed, and it can still go up to 50 is still what is guaranteed, and it can go up to 60. And memory 100 MB and 110 MB, let's say. So in any case it would not cross 110 MB of memory limit. So what is the significance of this? In Openshift environments or any cluster based environments, when you run multiple multi-tenant applications, you don't want one bad container to behave abnormally and then kill other containers that are running normally. Okay, so you want to restrict these containers how much CPU and memory they can consume at max, so that you won't see any anomaly in the running containers when you choose a multi-tenant mode. Okay, so my application is looks like the 100 MB is not sufficient, so that's why it's not really booting up. So what I need to do is increase the limit so that it can deploy. So you need to do some study before you basically choose how much limit you want to put on that. Okay, so looks like my 100 MB oh yeah, so it came up again. So maybe I choose a little bit more so that it won't run into any issues, but looks like the 100 MB it was able to make it. Okay, so as simple as that for setting up health checks and all for setting up limits. Yeah, looks like the limit is not sufficient, and let me go and increase a bit. Set resource limits, let me choose maybe 200 and 210 and choose 100 millicores and 160 millicores. Okay, let's see if that is sufficient. Okay, looks like that configuration is sufficient for application to run. That's all. And let's move on to other modes of deployment um, using Dockerfile and also binary deployments. Okay, I'm not going to cover these as a demo inside this video, but maybe sometime in future I'll make a separate video for this. But I'll give you some context. Okay, so how do you build a application based on Dockerfile? You basically write a Docker file in the same source repo. So one file with name called Docker file, and when you deploy it, it automatically detects that Docker file, and it will, instead of doing a source to image, it will basically do a Docker file based build. Okay. If you're doing it from CLI, you just need to choose strategy equal to Docker instead of strategy equal to source. That's all you need. So that will basically covers the Docker file part. And binary deployments. Um, so if you have built a war file and you want to deploy it to a Tomcat image and then make it as a container image, you can do that as well. I'm going to cover that in a separate video. For now, these are the primary features. I think I covered most of the important features of Openshift, at least in perspective of developer and operations. Thanks for your time.